All right, good evening. Thanks for that. Welcome to CocoaHeads. This is the March 25 edition. And we've got a few things lined up for you today. So as normal, or as usual, I would like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of this land, and pay my respects to elders past, present, and emerging. A little bit of housekeeping before. Obviously, for those that are in person, there's food and drinks available. Just go grab that. Hope you have had a chance to do that already. Otherwise, I'll be a little bit of break before or between the two talks, where you can stock up. Toilets are outside to the left, past the elevators, and yeah, if you want to leave at any time, that's fine. Just the elevators down and out the door, if you can unlock them. I am your host, Christian, for tonight. Zach he's on holiday in Japan, as far as I've heard. But he'll be back again next month, coming back to that as well. We have a code of conduct for CocoaHeads. There's a link on the screen on the website to the full version, but effectively it means just to be aware of people, be inclusive and be respectful. Common sense. We'd appreciate if we can make sure that everyone has a really good time. At the door, you might have noticed there was a couple of QR codes. It will be greatly appreciated if you can scan that maybe in the break on your way out, just to make sure that we sort of register who's been here and just security, all that. And next, we would like to thank our sponsor. It feels a bit odd that I'm thanking my own company, but yeah, thanks to Baloo for sponsoring these events. They have been for the past couple of years, and they are still going for this year. And we might also have a new sponsor coming up soon, so that's quite exciting. And we are also looking continuously for sponsors or people who, either individuals or companies who want to help out or support us or the community in any way. So that would be really great if you reach out. We have a Slack community. Or rather, the entire Australia and New Zealand has a joint Slack community for CocoaHeads. You can scan the QR code there. It'll also be up in the break. There's a couple of channels that are just really general. It's generally a place where you can find a lot of help and meet people around the iOS community or anything Apple, and honestly, probably anything outside of that as well. There's lots of good chats going on. A couple to pay attention to might be the jobs channel if you're looking or hiring. And then, of course, this meetup has the Sydney channel where anything sort of local to Sydney and this event will be posted as well. We also are, as usual, live streaming. We are pretty known to have the best live stream of CocoaHeads in Australia. If you don't know what I mean, you can watch last month's one. We would greatly appreciate it if you can, even if you are in person, go onto YouTube, search CocoaHeads Sydney, and subscribe to the channel and like the stream, because it just means that the algorithm starts to pick it up. We get a bigger audience, maybe a little bit more global audience, and people can get more out of it across outside of just the country. And I was looking at some of the past streams we've had last year with Phil. And funnily enough, just to give it a little bit of a demo of how it actually helps us, Paul Hodson commented on one we had last year, so it's getting noticed, and that's quite a big person to possibly support us. So that'll be really great. Do we have any first-time attendees? Great, got 5. That's a big number, actually. Give a little clap to them and welcome. Our friends in Melbourne have a similar meetup that happened last Wednesday. It's the third Wednesday of the month. No, second Wednesday of the month, sorry. Because we have the third Thursday. So was it yesterday? Last week, right? Is it? I'm gonna go on a limb and say it's the second Wednesday of the month. No, it's Thursday. Sorry. Okay, damn it. It's a live stream, we can't rewind. It's the second Thursday of the month, but they have a couple of sort of ad hoc events outside of that. That got thrown me off. Sometimes they do a coding night, then sometimes they meet up for, a social night. that sort of thing. Sorry, second Thursday of the month. This just shows why Zach is doing this and not me. But yeah, they've got a meetup page as well. If you're in Melbourne or want to watch their live stream as well, yeah, feel free to do that. They often have some different content than we do, so it might be worth a look. Coming up in September, we've got the Dev World Conference coming up, also in Melbourne. I'm not sure if they're actually looking for speakers and things yet, but anyway, they've announced the dates. So if you plan to be in Melbourne, or you can be, 2nd to the 5th of September will be one to put in your calendar now. Now we've got our usual segment for anyone who is hiring or looking for work to give a little presentation or just say a few words about themselves. I know that's at least one. So feel free to come up and share. Yeah.
Hi, my name's Hanisa, and I'm an iOS developer. It's my first time here as well. Yeah, I have about 3-4 years experience, and I have a computer science degree. Yeah, I'm looking for work at the moment. So, yeah, like I have been interviewing. So if you know if you have any referrals or any companies, please reach out. Thank you.
Cool. Anyone else? Excellent. As I mentioned before, we do also have that job channel in Slack, so maybe give that a look. And coming back to next month's event, if we're looking ahead a little bit, so the next one will be on the 10th of April, which is also, well, I guess that then clashes with Melbourne, because that'll be the second Thursday of the month. If it's I'm not sure if it's a Thursday. Very well prepared today. But it's a week earlier than the usual, and it's mostly because of the long weekend coming up. We felt probably a lot of people are going, out of town or whatnot. So, yeah. Plus, I'm going to be on leave. No, it is a Thursday. Okay, so I'm going to be on leave on the 17th. So it sort of was nice that we could move it a little bit back. Anyway. Yeah, we'll announce more details soon on Meetup and Slack. And as usual, we are also looking for speakers. So if you have anything to share, please reach out to myself or Zach. It could be a talk, it could be a product demo, as we also have today. It could be something you've learned cool. It can be a 5-minute little, lightning thing. It might not even necessarily be about technology or whatnot, just something cool you learned. Anything will be appreciated, so just reach out if you have any ideas. Also, if you are planning to attend in person, please remember to RSVP on Meetup. It helps us a lot to see how many are both interested, but also how many are going to be in person. So that helps us estimate sort of drinks and food and that sort of thing. And if you can do it as soon as possible, that helps a lot. Okay, enough of me. So tonight we've got 2 talks coming up. First will be Sushi, that talks about the good, the bad, and the ugly on dependency injection, which I'm looking forward to. And second, we'll have a little break in between. And then second, we've got Rachel coming to talk about an app that she's developing and a new product that she's planning to launch, hopefully sometime soon. Let's jump straight into it. Sushi, come on.
Yay! Cool. Well, thanks for everyone for coming. Hopefully you get something out of this. So today, as you know, the topic of the talk is the good, the bad, and the ugly of dependency injection. Quick show of hands. Who knows what is dependency injection? Ah, cool. All right. So I'm going to be critiqued a lot today. Again, who uses dependency injection. There you go. It's nice. All right, I'm about to be critiqued. Let's see. Look, for the people who don't use it, let's have a quick summary of what it is. You know, at the very fundamental basics of it, it's just a design pattern. It's a way of doing things. It's something that's encouraged because it lets you separate your code. You know, you have different behaviors within your code. You're able to, in theory, inject them. You know, and makes your code loosely coupled from your dependencies. And yeah, so that's basically what it is. Like, if there's any functionality, you know, you can swap it out. You can add it. You can do that kind of stuff. It improves the maintainability of your code over time. And also, one of the really nice side effects of dependency injection is testability, which I'll hopefully be able to demo nicely a bit later. And also, it encourages you to kind of slice up your code into smaller chunks, which can even be used across different apps in the future if you ever do need to refactor or, you know, build up your app ecosystem or something. The plan for the next 30 minutes or less, I don't know, I didn't time this. I just needed a catchy headline. I want to explain that there is, you know, multiple ways of doing dependency injection. There's no one right answer. You know, there's basic ways, there's, you know, more nicer ways, and there's more complicated ways. They all have their advantages and disadvantages, but just, you know, you got to find a nice balance for the app that you're building. Literally what I just said, just trust me, bro, there's no right or wrong answer. Yeah, there's no silver bullet. For later on, you know, I'm going to show some code samples a bit later, so you can go to that GitHub and have a look. Might not be live yet, but yeah, that's fine. I'll make it live after the talk. Cool. So let's do one of the most basic injections that there is, called constructor injection. With this one, you pass in the dependencies that you want when you initialize the object that you're looking to create. So if you look at the code sample on the right, the data service, it gets given the database as part of its constructor, right? That's why it's called constructor injection. It works really nicely with testing. You got the compiler working for you. If you remove your dependency, or you decide to remove it, your compiler will tell you, you know, you need to fix, you know, these 20 places in your code. It's really nice in that sense. But one of the downsides of it is it can grow and become difficult to manage as your number of dependencies grows, you know, or if you have dependencies which are, you know, a few levels deep. Do you pass them down from the top level? You know, how do you kind of take care of that? That's one way. It's also, you know, sticking to the no library approach. There's another way of doing injection called property injection. Basically, what you do is you just set some sort of value on some service. So like in this example here, we do service.database, and you basically give it, hey, this is your database. So going forward, any call to that service will use that database. This becomes harder to test because let's say you forget to set the database, you know, you get memory leaks, or you have to handle optionals and all that kind of stuff. If anything, it's something that, you know, encourages the use of testing. And this also comes down to one of the themes which comes up a little bit later, where you can actually get some runtime crashes if you don't set up your dependencies properly. Where in this particular example, if we remove the .database assignment, the print will fail, or it will crash actually, right? And probably the last vanilla, let's call it vanilla, way of doing injection would be where you kind of pass in the thing that you're trying to use. So if you're doing service.load data, you give it the database every time you call it. This could be, you can think of it it kind of reminds me of like a stateless web server where you have to give it everything it needs in order to do its job. Yeah, that's one way of doing it. Yeah, so look, those three kind of make up the basics one. But I wanted to quickly do a quick demo of how you do construction injection, if I could find where my mouse is. Why can't I go back? Why can't I go back? I really can't go back. My mouse is gone. My keyboard's not working. Oh, wait, it locked.
I'll just escape.
No.
Give it a reboot.
Turn it off and turn it on again. Okay. I've actually never rebooted this. You just hold the power button, I assume. There you go. Okay. Please wait.
Problem is my keys. It actually works.
Okay. All right, we are here. All right. So, where were we? All right. So I gotta get my notes up. So sorry, 1 second. So I'm gonna run the first example just to give you guys an idea of what is this app that we're dealing with. It's a very basic app which just displays a message when it decides to load. That's not meant to happen. Okay. All right, cool. There's our message. So it's basically, you press the message, it gives you a new message. It's a very creative app, right? And it goes in a circle, essentially. Keen eyes might notice that it's all rainbow colors, order of the rainbow, whatever. But the point being, that's what it's doing right now. Yeah. So basically, the way it's working is I have inside the app we have a message which is just text symbol tint. Sorry, that's hard to read, isn't it? Better? Extra large? Even better. All right. Yeah, so we have a message bank which just contains literally just a bunch of messages, text symbol tint. Like I said, currently in rainbow order. Make what you want of that. And then we got a protocol for getting the messages. So this will just return a message to the view for what needs to be displayed. And then we have actually a bunch of different message services. So we've got 3 different message services. The one that I'm pretty sure this is the one we were using just now. Yep. So this is called just a sequenced message service. It just goes through that array of messages one by one, displaying the next one. Or there's another one we can use, which I've also implemented, just a random message service, which literally just returns a random element. Or we can alphabetically sort them and then do the same thing as the first one. So there's 3 different ways of doing the same thing. The way the view is set up is literally, put that aside. We've got the state object, which contains a view model, which is a view model, sorry. That gets given the message service, which gets given a message bank, right? So you've got 2 dependencies. One depends on being passed into another one. You can see that it can get messy because, what if it was 3 levels deep, 4 levels deep? You have to pass it in from the very top or that kind of stuff. Who's responsible for creating the dependency? In terms of display, literally you press a button, it updates a message, and then the message gets displayed. Nothing's too special there. Yeah. And then from testing perspective, just to show you guys, if I remove the min map, it's all a bit easier to read. We could create a stub message service, again implementing that same protocol that we looked at a second ago. And we also give the stub message service its next message, that kind of stuff, and then we check that the initial message is correct and next message is correct. Don't need to, but let me just run it. You see the test run just fine. Whenever it starts run, and there you go, ran. It's a very basic one. There's nothing that can really go wrong. This is kind of just kind of foreshadowing what's coming up a bit later. If I run this test repeatedly 100 times, it'll run just fine. Oh wait, let's wait for it to build and then run. It runs just fine. But yeah, it works. That's all I really want to say about that one. very, very basic, right? But you can see we didn't use any libraries. It's very simple. You've probably used some form of this, somewhere in your apps in the past. But this is the basics of dependency injection. It's not just a Swift thing. You can do it in any language. It's out there. Yeah. So let's return to Keynote, and hopefully it won't crash on me this time. I'm just going to leave it open. Actually, no, let's go. Let's take the risk. So the next kind of dependency injection I want to talk about is service locator. So this is basically where you kind of offload fetching of the dependency to another sort of class. It looks a lot bigger because at the top I've created like this resolver sort of thing, which you can give it a dependency. If somebody needs a dependency, you tell add, and then when somebody needs it, they resolve it. There's no need to pass around dependencies. You just get it from this resolver. Just for convenience, I've also done resolver.shared as a static because singletons are sometimes awesome, sometimes they're dangerous, but in this example, it makes it really easy to use, right? All we need to do is just at the very bottom, you can see we just do service.data service, and internally the data service gets initialized, and its init gets called with the resolve. But obviously, if we don't register the service, it can actually fail at runtime. So there's no way to really know if that's going to fail. So you need to thoroughly make sure it's set up. You do obviously have the compiler telling you about implementations and that kind of stuff, but whether or not something is registered, it may not be there. Yeah, that's basically all I really want to say about that one. Again, let's do another demo, and my escape key worked this time, so that's good. Cool. So let's do the service locator. Again, same as last time. Not very exciting, but let's just run it again. Exact same app. The only thing that's changed is the title. App works exactly the same way. And like I said before, the resolver. Just for convenience, I've just put setting up the dependencies, the .add dependency code that I showed in the last screen. I put it into the constructor. You probably don't want to put it here. You want to put it somewhere else. But it basically says that if any piece of code wants a messaging service, give them a sequenced message service. If any piece of code wants a message bank, give them a shared message bank. But this is kind of one of the cool things. Unlike the last example, we can actually have a fake singleton in a way where if somebody asks for a message bank, you give them a message bank which was previously created, but it's actually just a previously created instance, not actually a singleton. So if you had another resolver for whatever reason, you would return a different message bank. Whereas in this scenario here, up here, every time somebody asks for a message service, you give them a new instance because this particular closure gets run, right? So you get that little bit more control, which is actually pretty nice. But obviously, you then need to decide where you're going to store this. Hold on to this reference for yourself, right? Another thing to consider is if you're running SwiftUI previews. Let me just show you guys this. If I bring up the preview pane, the SwiftUI preview is just set up like this, right? Ignore my comment, which obviously gives away what I'm about to say. The preview works just like the main app. That's because under the hood, the way that SwiftUI initializes previews is it actually launches your app, and your app did finish launching. It actually does get called, weirdly enough. So in our particular case, it's it's launched our app. It's called Content View, which if you kind of drill down, then creates a view model. If you drill down again, which then does resolver.shared, which initializes the dependencies, and that's why it works, right? So this is basically it's using the same dependencies as the main app, right? Even though we haven't done anything special, which is actually pretty nice. Yeah, sorry, what else? Another thing with the resolver is, we are force unwrapping in a few places. This is obviously what causes a runtime issue, unless you want to actually handle the runtime dependency, the failure to resolve, which, I don't see any way to handle it. If your dependency is not found, you probably want to crash, I would say. At least that's how I've thought of it. Yeah, that's it. Sorry, let me see my notes. What else? Yeah, and obviously the last thing I want to really point out is the tests. They haven't really changed much. Exactly the same thing. We set up the next message, the same stub that we're using before, because we're still using a protocol. The biggest change is if I run this test. I run the test. Right now it will run just fine, as you can see there, but that's because I've also got .serialized enabled. So this is Swift testing. Now if I run it, it might run, it might fail, might not fail. Oh, look, there you go, it failed. Since we use a singleton, things can get a bit weird. So if we just try running that again, sometimes it actually does pass. There you go. So it's very, very flaky, right? If I try to run that test in a loop 100 times, guaranteed to fail. That was one.
Can you explain why it's failing? Like where is it
it's
not setting up the
it's because the way that what you call that Swift testing works is by default does it in parallel on that one device, right? So the dependency may not be initialized, or they may be swapped out or something like that. It just, one of the things. So the way I had when it ran the first time, it was actually set to be serialized, so it only run one test at a time. Which, as your app code base does get bigger, it will get slower. So if I run this 100 times, it'll pass, but it'll be just a little bit slower than it could be, right? We always want to get the most out of our chips. Yeah, so let's move on to the third type. Third-party libraries. So libraries are there to be used, right? So I want to give an example of using a library called SwinInject. SwinInject is a nice library because it's very similar to the last thing that we looked at, where we have the .register and all that stuff, and it resolves. By doing .container, for example, it ensures that it's a singleton, as in it's a fake singleton, meaning that block of code will only be invoked once, so your object its reference will be maintained by the library. You can do .weak, so it will maintain a weak reference until all your code has let go of it, and it itself would obviously free it up, which is also very nice. And also you can even set up like hierarchies of the containers is what SwinInject calls, that kind of manages the dependency, right? So you can set up child containers. So you can say that, maybe this flow has, can inherit from this particular container structure, and this flow can from this other structure. You can really shape it however you really want to, sort of thing. Yeah, that's really, there are a bunch of other stuff in SwinInject, but those are the ones which I really find interesting. You can read into it. To have a quick demo about this one as well. So just like before, it runs exactly the same, right? But one of the nicest, so now if we look at how it's kind of set up, we've got the register and resolve. I've done a bit of a wrapper around SwinInject. So if you do ever want to replace swing inject with some other library, you can. So this is the only class that references swing inject in this project. So you can see you just do swing inject container dot resolve, swing inject container dot resolve, that sort of thing, and sorry, dot register. Yeah. When the app is initialized, it uses the resolver for the app, which is thus this static function that I have. It just creates contains empty resolver, sets up the dependencies, and returns it. So basically, within the app, we create a dependency resolver for the app, and we pass that into the main content view. So as a pattern, now we're passing, rather than passing around, a complex structure like in the very first example, we're just passing around this one resolver or container or something, right? Wait up, it can be a bit annoying. Maybe you have to pass it around everywhere now, but its benefits kind of are pretty cool. I'll get to that in a minute. Sorry, and like I said, if I just drill down into this, the resolver, it gets passed down, it gets created, passed also into the view model, that kind of stuff. So sorry, just backtracking a bit. So we have the dependencies for the app, and then we can also do dependencies for preview. So unlike the last example where the content view was just using the dependencies that were in the app, we've actually done content view and then dot for preview. Now we actually have a new implementation of the resolver. So this one, if I just quickly kind of open it, you can see, where is it? Messages. What do I call it? Preview message service. All this really does is it's got a bunch of colors. So it's only cycling through 4 colors, and then it picks a random a sequential SF symbol, right? So, and maybe you have a use case for this, right? Inside your content view or whatever, your previews, you might want to not even connect your previews to the live services, right? You want to stub them or something. So it's really easy to do that. And so the way that it's set up here is in the last one we created a empty resolver, right? Create empty. In this one we're creating one for the app, and then we're overriding something. So in this particular case, we're overriding, if somebody wants a message service, we'll give them the preview message service. And and you can see it's really neat in that this is the only place we kind of really have to reference it. Yeah. Any questions so far? No? Yeah.
You passed the this container
Yep.
via in construction.
Yep.
If it's purely SwiftUI, could you use like environment?
You could use environments as well.
Construction all the way down if you had to pass it through.
Look, at some point you will leave SwiftUI, right? You will end up within models and that kind of stuff. So environment doesn't really work down there. So that's just to maintain that pattern. That's really the reason I kind of did it that way. Anything else? Yeah. Okay. And now the nice thing with doing it this way, in that we start with inside our test, we start with an empty resolver. We set up everything just like we did before. But the nice thing is, since this resolver is unique to this particular test, it actually runs in parallel. So now, just like before, we can run the test suite. You obviously all pass, but we can run it in parallel. You can run it repeatedly in parallel, and it will also pass, because every single iteration of the test will create a new resolver, which will create a new set of dependencies, and then those are then passed into that, just unique for that test. So you're guaranteed that there's not going to be any singletons kind of getting in your way and that kind of stuff. One of the nicer approaches. Yeah. Any questions about that before we move back to the slides? No? Cool. So just a quick summary. What we kind of had here was we had, you have the view and the view model. You're injecting the message service into it. Into the message service, you're also injecting a message bank. And then, the message service would be implemented in a bunch of different ways. So we have the random message service, the sorted service, the sequence service, And if we're running in SwiftUI preview, maybe we're using the preview service. But at the end of the day, the view and the view model, they don't know what they're kind of hitting, right? Or even like, for example, if you're running the test is using the stub message service, right? So it's all kind of, unknown to the view and the view model. You can change the behavior without modifying your code. You can test all the edge cases and everything, which is what the point of, the one of the points of or advantages of testing with dependency injection is. Just coming to the end, just something to keep in mind. Try to always use protocols. So I use protocols for our message service. That makes life so much easier. You want to swap out something, protocol is a way to go. Avoid singletons as much as you can, which you can kind of see is the advantage with the third example. We didn't have a singleton, so it was really easy to just swap it all out. Run it in parallel. There wasn't any threading issues or anything. And some things you can kind of keep in mind, which I don't know. Some apps I've seen this happen, some I don't. But Apple does provide some sort of mock and those kind of things for stuff like biometric and GPS. Don't rely on those. It's probably better to more rely on if you build your own wrapper around biometrics, around the GPS. Have your own callbacks. That way your test can kind of control that as needed. Keychain, user defaults. You can have a keychain which gets destroyed with every test iteration, right? Otherwise, keychain gets persisted on device. Same with user defaults. You can just keep it in memory as opposed to writing it to disk. A very common one, which is network. You might want to swap out your prod to a non-prod, to a stub, to something else, right? That's very, very common. One which, to be honest, I've always wanted to do this. I've never had a good project to do it on, but kind of dependency injecting date and time. If you think of any sort of tests, which I've had flaky tests which are related to time, after 5 minutes, less than 5 minutes, time zones, that kind of stuff. But this is a great way of trying to wrap it and that kind of stuff. And of course, like similar to the whole keychain user data, user defaults that I was mentioning, was you could even have like core data. So every single test iteration, you could create a new core data database potentially, and it's that your state is in a state that you can control. Yeah, so that's kind of all I really had. Any questions?
Yep, I'll start.
Yeah.
First of all, thank you. The daytime one is interesting. I had that problem that you described where we had tests that had specific formatting or string formatting and things, and then depending on whatever locale the test machine was set up to, or the whatever, it could change all over the place, like, or time zone and whatnot. So what we did was exactly that, like wrap date itself in a resolver, and just you could inject a hard-coded date for testing, for example, or something like that. So that's really cool. Same for location and that sort of thing, like that can change. Very interesting. My question is around, so in your experience, what sort of your thoughts on when to create your own little resolver, because it doesn't take much code to create that thing, versus when to use a framework for it? And likewise, how do you decide what to sort of inject the constructor, for example, a view model, versus what do you put in your dependency injection system? Because you wouldn't put a view model, for example, in there or something like that.
So to be honest, usually when I do my stuff, like I avoid the first one, the constructor one, as much as it is vanilla and does a job. It does a job well, especially with the compiler telling you what errors there are. I usually tend to go with the second example, where it's my own class, 10 lines of code. And I didn't demo this here, but I also have a property wrapper that I use. So it just makes it just a little bit easier to set up the dependency. But in larger projects, it actually does make sense to use a library, mainly because you do have a lot more control over how it's set up and that kind of stuff. But even if you look at that last example I showed you with the the .4 preview and the .4 app, that's got nothing to do with the third-party library. That's just the evolutions built on top. You could swap out the library with the implementation in the second solution. Yeah. So yeah, second solution with property wrapper, which I didn't show.
And how do you decide what to put in the dependency system versus what to just pass in by
Put everything
whatever?
into the dependency system. That's how I try to do it. It does get messy. Like I remember the project I worked on once where we did put everything into there, and then on the SwiftUI preview side, it meant that we also had to set up all our initial models. So all the data, all the pre-filled data had to be set up. Like it was a core data. We had a core data database. We had to pre-fill all the data with every single test. So it meant like when you just to launch any preview, you had like this much code that got ran. Fine, it was all hard coded and all that, but it did the job. But the point there was everything was dependency injected for us. Yeah.
Any other questions? All right. Well, thank you so much, Sushi. We'll have a short
you.
break and return shortly.
I don't agree.
All right, we're gonna continue to the next segment of the evening, I suppose. We've got Rachel here that's going to talk about a product or a project that she's working on based on some hard research, which is quite interesting to hear about. She's going to tell a bit about the story and what she's working on and sort of that process, and then we're going to open it up to the audience to just have a bit of more of a conversation, and then let's take it from there. So, welcome, Rachel.
I'd like to thank Christian and the rest of the group here for inviting me to talk today. I must say that the last time I spoke about this was at I spoke to the AI in Medicine group at University College London, so it's a bit of a while. The QR code that you will see now,
There you go.
that QR code contains links from a pretty awful webpage of mine to 3 talks that I've given, the PDF files, not the PowerPoint. The talks are, one I gave to a group of lay people, so that's sort of a simple version. Not necessarily this app, just the general principles of what I'm doing, monitoring wellness. The second one was given to a group of Australian mathematical psychologists. So you might like to infer that I am a mathematical psychologist. All that means is I work in psychology, but I'm a mathematical modeler. So I use a lot of computing as well for the modelling. And the third one, I think, you'll see it's a London red bus in front of the Australian High Commission in London. I think you might think that might be my talk to the London group. Anyway, you're quite welcome to access the previous talks if you wish, and that'll fill you in on the details that I don't have time to talk about today. I have invented a trademark. See how optimistic I am. It's called Psych Tech, as you can see. It's registered. When I'm talking to clinical psychologists and psychiatrists, I call it Psych Tech. And when I'm talking to the other types of doctors, it's handy to use the pronunciation Sick Tech, so it works in both ways. Anyway, so the idea I've called, this is the name I've called the app actually, and the app is designed to monitor wellness. Now, the reason I've done this is because I was caring for a loved one for quite a while, diagnosed with a serious illness, and whilst caring, I had the opportunity to, use mathematical modelling and a whole bunch of other things. And I developed a technology based upon what's called multifractals. You may not have heard about multifractals, but actually Mandelbrot wrote some of the earliest works on this in 1967, actually, it's a long time ago. It turns out that just about everything we know is multifractal. Our heart rate is multifractal. The atmosphere. Name anything that people measure to detect whether climate change is going out of control or not, and that is multifractal. It turns out that if you are pressing a button as fast as you can for 2 minutes, as is one of the tasks in the app, that is multifractal. By the way, there's ways of telling it whether it's multifractal. I'll mention that in a minute. The other interesting project we did was to have someone track a randomly moving object around a screen, and the tracking error is multifractal. It's quite magic, actually. But the important thing in the app that I've done that you can access, so I've got a test flight link there which you can try if you want. If you've got a health kit compatible device, Apple Watch ideally, but it could be a Fitbit or some of the others for which there's an app to translate the output of those devices into a compatible file for HealthKit, then you can use that. That should work. What it will do is it'll take the data over the last 2 days, heart rate data over the last 2 days, analyse it in a fancy multifractal manner, and print a single index which represents the amount of multifractality. I'll use that as a terminology, but I've translated that for us ordinary people into a heart, what do I call it here? A heart index or something like that. But it's not really heart rate. In fact, many people in this field use heart rate variability. And if you look at the output of your health app, you'll see that it measures your heart rate variability. And there's a competitive app to this one that I've done that was developed by a team in the UK. I actually had a chat with their CEO last July, and it's called Visible. I don't know whether you've heard about that app. So if you go to makevisible.com and you'll see or read all about it. It's being used to monitor people who are diagnosed with long COVID, which seems to be quite a problem. They use heart rate variability. The interesting thing is when I'm computing my heart index, I remove from consideration the average heart rate and the heart rate variability. What I do, in fact, is I take the difference between successive heartbeat intervals. And so in a sense, I do remove some of that variability, but I make sure that the data is from one time point to the next independent. So for those of you into statistics, there is no autocorrelation. So I'm cancelling out all of the linear properties of the heart rate and only concentrating on the multifractal. Now, for those of you who have taken a flight recently, you may have experienced turbulence. It's fairly common. I'm measuring heart rate turbulence to be more precise. So the basis for doing this is that heart rate variability has been shown to decrease when people are unwell. In fact, if your heart rate has no variability, it's not the hospital, it's the morgue. I'm sorry to say. So there has to be some heart rate variability. It can't be like a clock. That's bad. So heart rate variability has been used, and it's used in this Visible app, shall we say the competitor. And it indicates whether people might be unwell physically or mentally. But as I've just mentioned, it's a complex signal, and I'm looking at the complexity of the signal. So the wellness index that I compute is takes data from any compatible wearable device, compatible with HealthKit, and I compute the index. And what we've done in 2022, I had a student compare performance of that index over time with how they rated their wellness using a scale called the WHO, which is, as you might have guessed, the World Health Organization. It's a very simple test. It has 5 questions. It's supposed to be very useful for those with chronic conditions such as diabetes. And it also seems to be the case that if you score very low on that test consistently over a time period, you may get a diagnosis of depression. So there may be some relation to mental illness as well. So that was a little encouraging. And so what I did was I took the research I'd done, shall we say, in human psychomotor skills such as reaction time, which is tapping, tracking, and I've incorporated that with the WHO 5 quiz scores. And just for good measure, in case we want to measure the elderly, like I'm becoming, it would be rather nice to do a mini mentor, which is usually you say a few words and the person at the beginning of a test or a discussion doesn't really, maybe they're not really paying attention. You ask them to remember this. And then you give them a lot of intervening things like tasks to do. And then surprise, surprise, you ask them, do you remember seeing this one? Do you remember hearing this one? So I've included a mini mentor. So what happens is that the full version of the app contains all these extra tasks. There's 5 altogether. And if you look at the last slide, I hope you can read it. In fact, I can hardly read it myself on here. There's scores over time. These are my scores, actually. Over time for 5 tests. And if you look at the quiz scores, and if you look at the heart index scores, you'll see that there's 2 little dips that occur at rather similar times. Well, this was a flight I took last July, the long haul to London from Sydney. And this, I think, was the 2 dips which happen when you're pretty exhausted after the flight, and then afterwards you're still continuing to suffer from the jet lag. So the technology that I've developed here is quite subtle. I got some data from some people in Western Australia. There was a psychiatry group, and I asked them, I said, don't tell me what's wrong with these people, and I'll tell you, and you tell me if I'm right. This is the good test. I got it right. I picked the 2 people who were diagnosed with depression versus those who weren't, except that I said that those who weren't, who happened to probably be the people who sent me the data, right? I said, there's something wrong with these people, these other 2. What happened? Oh, look, we both went on long haul flights and we're still a bit jet lagged. So it's quite interesting. The one thing that did encourage me to pursue this project, actually 2 things. Using offline data. In other words, data that is not coming from any of these devices. So this is data that people have supplied to me. It's possible to pick up the early signs of a bipolar disorder relapse leading to hospitalisation for mania, which is not uncommon for people diagnosed with bipolar disorder. This technology can pick up the early signs of that 2 weeks before hospitalisation. If you ask a psychiatrist, what can you do in 2 weeks before having to hospitalise someone who's unwell, they can think of a whole bunch of things to do. So we can save a lot of money. Imagine how much it costs a private health insurer to put someone in that situation, maybe not quite manic, but unwell, into a private psychiatric facility for 3 weeks. It's a lot of money, actually, we can save. So maybe I should talk to private health insurers. The other thing that I was quite surprised to pick up was I said, this person was very, very unwell at this point, and the whole record stopped. And yes, they attempted suicide and rushed off to the hospital. I picked up that downturn 2 to 3 days before it happened. This could save a life. The idea is that people will wear their device, whatever it is, and they will have the monitoring going on, and messages can be sent to the medical team. And if a signal comes up, they go out and see what might be wrong. Because otherwise doctors don't have a clue, do they? They say, come back in a month. They really don't know what's going on. Anyway, so my possible applications, I think there's no limit to the possible applications of this technology. Long COVID. I think this can be competitive with the Visible app. Maybe anxiety and depression. There's a big market for that. Bipolar disorder, sure. Any chronic illness such as diabetes. But just to bring in even more people, just normal healthy living. If you look at one of those talks that in that link, what happened was I gave myself almost 12 months of let's monitor myself with my Apple Watch. You do these things, don't you? And I took the data, this is the offline version, and I took that and I analysed it. And when I was being very good, like I was having an excellent diet, no sugar, no McDonald's, no fizzy drinks, 10,000 steps a day, rain, hail or shine. And the index went up and stayed up. So this suggests, this is a healthy lifestyle. And then I had a medical thingy, And when that, and this was overseas, and when that happened, the index precipitously dropped. It decreased. And then when that was, during the recovery period, it increased, and then it went back to baseline because I wasn't quite so concerned about my health at that point. I didn't bother with the 10,000 steps, and I had a little chocolate and maybe went to McDonald's. So I'm quite convinced, given some of these talks are based on papers I've put on preprint service. So it's not as if and there's been quite a few downloads. I've been trying, because I'm a retired academic, I don't need all the publications anymore. I've tried to be a bit discreet in terms of publishing the material in the journals, mainly because I got rubbish reviews, because they don't understand multifractal technology, partly. And the other reason, of course, is to keep it in-house as much as possible, although, as you know, preprint servers are internationally available. So what I've done at the moment is I've written this app in Swift UI was really the saviour for me, because it was more like the normal programming language that I was used to, rather than the previous version of Swift. I had the problem of, how am I going to take the R routines, which are quite complicated to compute the multifractal spectrum. I also have another, I didn't show the screen, I have another screen that takes all the 5 measures and it stores them in what I call a novelty-sensitive associative memory. I'm not sure whether that makes sense to anybody, but it's a sort of system I've used to model human memory previously, and it works for predicting how people perform in memory tasks. So I thought, why not use it here? It almost automatically, by virtue of the algorithm, computes the principal components, which is that's a technology that's sometimes used in AI. So I've called this simulated real intelligence, which I think is probably a better way of putting it. So that's the measure I'm trying to, this is not finished yet, trying to monitor overall to detect whether there's going to be a precipitous change that might require notification to the person, their carer, their medical team, depending upon the approvals, of course. So this is the app. The app that you can try is merely the heart rate bit of it, mainly because I didn't properly archive the full app a year ago or 7 months ago, and so I have to reconstruct some of it. I mean, I have all the programs, just have to reconstruct it in order. So I'm using the Accelerate framework. Has anyone used that? It's very, very useful. It means that I don't have to send the data into the cloud or wherever to do the calculations as if they're being performed by R. I can do them very, very quickly. If you run that app, I know maybe some of you might have written down the link. I should have made it easier for you to do that. But you can count to 5 or 6 and out comes the answer. So Accelerate does all these calculations very, very fast I've got an iPhone. Have I got a 16? It's hard to know. It probably is. It's a fairly fast iPhone. But so Accelerate framework, I think it uses the GPU, and also I think it uses maybe the neural engine as well. So it really works fast. So at the moment, you can try the heart rate version. My son thinks it's a bit Mickey Mouse in terms of how you go from screen to screen. Well, I'm not a professional iOS programmer, but it works. And I'll try to produce the proper version, which maybe show you next time. Does anyone have any questions about all this?
One maybe. So the heart rate or heart index score you do, if I understand correctly, you're not really able to sort of detect what might be wrong. You can just see there's something that is not quite as right as it should be. Is that
yes?
Right?
This is the thing that this is in a sense the limitation. Unlike a medical practitioner, I'm not going in for a diagnosis here of a specific disorder. I'm detecting whether there's something that is maladaptive. What we do know is the heart rate is multifractal. And what we do know is that there's lots of aspects of our environment that are multifractal. My feeling is that when you get the flu, there's something gone wrong in your bodily system that makes it hard for you to maintain, shall I say, access to the complexity of your environment. So what do? You go to bed and rest until you get back into, and same thing with a depression, I suspect, into a situation where you can deal with the complexity of the environment. So what the heart rate measure I'm using, it's measuring your complexity. And presumably if that goes down, it means that the relationship between your complexity, which is now reduced, and the complexity of the environment, which will stay reasonably constant. So that difference is going to mean that you are not well. I mean, I've never heard a doctor tell me what unwell really means. But this I think, is getting a bit closer to it, because it's how well can we deal with a complex environment, a social environment, physical environment, whatever, internal environment. So yes, it's not specific. That's for sure.
So would you be able to, have you seen that your data sort of starts to pick up these signals before people feel symptoms, or like how early do you find that you can detect things?
Yes. I was very pleased to tell there are a few NHS bosses at my talk, I must say, at University College. It was quite nice. I was able to tell them because, I mean, the head professor is the BBC first spokesperson for COVID. BBC was going to her, Professor Pagel. She wasn't in my audience. It was just a talk in August. She was on holidays in Iceland. I mean, I don't blame her for doing that. But so what happens is that I show them information using data I got from people who were infected with COVID in a study conducted by Stanford University. And Stanford University were very generous to put all the data on a public server, which saves me all the problem in getting data, right? So what I did was I showed that you could predict the first signs of COVID infection for some people up to 10 days before the symptoms emerged. Now, you remember COVID, actually still lingering along, but the situation there was that the idea is if you're infected with COVID, stay home. That was, and they even locked us down but in general, if you know that you have an infection, the first experiments that showed this were with respect to flu, by the way. Then, before the symptoms appear, you can just stay away from people, because you get a massive decline in the measure that I use. And I was playing in an orchestra rehearsal. No, that's right. I played in a chamber music group the Sunday before last, and a message came around and said that one of us had COVID, right? So be wary. So what I do, I checked my app to see whether my heart index had dropped. And if it had dropped, I would have given myself a test. But it hadn't. So I'm still okay, I think so. Anyway, so my feeling is that if there's a group of iOS experts who want to make a lot of money, this might be one way. Because there is nothing that exists quite like this in the field of health wellness monitoring.
Which actually fits well with the end sentence you had there. Is I was just wondering a couple of things, apart from whether your son's opinion about the UX needing refinement is, where do you want to take this? Do you need to go through peer review, journal, etc., to prove that the models that's giving the predictions are right? Do you want to make it commercial? Do you just want to make it that it helps people's health outcomes and predictability? What do you plan to do with what you've got so far and the stuff that you're working on, and how to get those R numbers, etc.?
Well, there's one possibility that once I have a working version, thanks for the question, once I have a working version of the full app, I can then run an experiment via the University of Newcastle, right, so that I can acquire data from all sorts of people and we'll see what happens. My biggest problem there is I haven't had anyone from the University of Newcastle actually tell me that they're interested in doing this project. And that makes it rather difficult because I'm only one person. That's not the reason for that is simply that they're already busy with their own projects. It's nothing to say against the University of Newcastle. It's very difficult. I mean, the thing is that if there is an app that does this, that satisfies the sorts of requirements that you people would demand as experienced iOS developers, then there's no reason why it can't go out and be used by people. And each of those people can approve that you use their data. And then you get the data and you write the paper. That would be my best approach to it. I'm not getting any younger, so I'm anxious that something be done because I think the benefits from using this sort of technology are quite considerable. So anyone who wants to, I mean, I don't have $1 million to hand out to developers either. That's the other important issue. So. I mean, this works. I mean, if you want to put it bluntly, it works. It doesn't look. It's not up to standard. I don't think I may not get a high distinction computer science course from this, but and you can look at it and see that it's not absolutely totally professional. But I'm an amateur writer of Swift UI programs, to put it bluntly. So.
Maybe you need a trip to Shark Tank.
A trip to it?
Shark Tank, or whatever it's called. Is that the Australian equivalent? Yeah. Get some VC investors and things to get it.
So what's that called again?
Shark Tank.
Oh, Shark Tank.
Yeah.
Is that's not a TV show, is it?
Yeah, it is.
Yeah.
Oh, oh, I wasn't thinking of a TV show, but yes, it's. I actually went to one of those once. I was in the audience. A colleague was presenting, and I thought I'd be a little bit, supportive.
Well, we have a question here.
Yeah, not sure I understand correctly. Maybe you can correct me. Heart index is something derived from HRV, and if it is it correlated anyway, or it's its own metric which is more indicative or predictive than HRV alone? Because I know a lot of apps, like even Apple itself, but maybe Whoop, they all try to use HRV nowadays to derive all sorts of insights.
Yes, the thing about that is that I've done a lot of work in nonlinear systems from the mathematical perspective. Heart rate variability is a linear property of the heart rate. What I do is I compute the raw, using the raw data, I compute an index that measures the amount of multifractality. The raw data is the differences between successive heartbeats, or successive measures of heart rate, to be more precise. The only reason I use the successive measures is to get rid of all the autocorrelation. It turns out the heart rate series I get from the Apple Watch, at least, is autocorrelated with lag 1. So if I take the difference, I have completely independent observations, so there's no problem there. So I take the raw data, and the question is, I want to know whether I get my index, one number, right? One number from the raw data. I want to know whether it is nonlinear and multifractal. So what I do is I take and this is why this Accelerate package is so useful. I'm doing this in the while the app is running, in the 5 seconds while you're waiting for the answer. What I'm doing is I'm taking all the heart rate data, and 20 times, roughly, statistically speaking, 0.05 is roughly okay. I randomise the data, scramble it, shake it around, whilst maintaining what I get out of doing that each of 20 times. The mean is the same as the original data. The variance is the same as the original data, and because I've taken the difference, I don't have to worry about the autocorrelation. So what I'm doing is I compute the heart index for each of those. We call them surrogates. And that gives you a distribution for what happens when there's noise. So my heart, what I'm doing, as opposed to all these other people, I'm making the heart rate variability just be part of the noise. And what I'm saying essentially is that, is my measure that I get part of that distribution or not? Well, if you look at the measures that come out of that app, if you want to download it and run it, you're getting measures. I just measured myself before I came here, 3.5. Now, these are standardized normal deviates. So that's a Z-score of 3.5. So the chances of that happening purely by chance in the noise is, 1 in a, 1,000 or something. I don't have my normal distribution table in front of me, but it's fairly low. Now, you're not always going to get those numbers. If you have a bad night sleeping, I think if you don't sleep very well, it will drop down. What happened was I had a chest infection and it dropped down. I went and had a shingles inoculation vaccine, which people my age get, and I was infected, if you want to put it medically, and it went down. So I do use it to see how I'm going, sort of, more or less. At the moment, it's reasonably high, so I'm quite confident. I think this technology has great potential. Look, I'll keep nagging the medicos to see whether there's some possibility of trialing it for various whatever. Are there any?
Yeah, I've got one. It's very interesting. So my question was around: are you able to? Let's put it right. So I think this is a great sort of screening tool, right? To see something might be up, I might need to go to the doctor and things, check it out. What I'm thinking is, would your numbers reflect like sort of the severity? Like I'm thinking, because today, if you go to the doctor, like to be able to know the difference between if it's like a virus thing, like a cold or something bacterial, you need a blood test or like a blood sample, right? Do you see any correlation in your index that might help indicate, do I even need to go to the doctor? Like, is it serious enough that I need someone to check this, or is it just a bad day? Or like, do you have an opinion on that?
Well, the problem I have at the moment is, look, I am using heart rate, which of course the doctor, have you noticed how the doctor does regularly check this? They take about 1 minute to do so, but we're taking 2 days. It's a bit better. Look, I must admit that I can't really say that anything definite about what has gone wrong. Look, if it's a cardiovascular problem and the person is near death, then it's going to be very low value. I can certainly say that. I think we can be pretty sure about that. But otherwise, it's very hard to be specific. But I don't know any other way of measuring our overall wellness. I mean, they try heart rate variability. I get rid of it and get a very sensitive signal, maybe even more sensitive. So,
They're doing predictions of heart rate variability, which has already had an assumed algorithm to produce the number, and then they're making predictions. You're using a completely different way of analysing heartbeats.
I'm using everything except heart rate variability and getting really impressive results.
But a completely different model to go.
Yeah.
What are these numbers telling me, and then applying it to the other questions, etc.
Yeah.
Then come up with.
Yeah.
Okay, there is something indicative. which could be
Yeah,
measures.
yes, it could be anything. I mean, look, if the person's diagnosed with, say, bipolar disorder or depression, then we know that they're approaching maybe an episode. And it would do no harm to invite the community mental health team to come and check on them.
People could self-diagnose and go off their medication or whatever.
Well, it could be anything. And speaking to community mental health teams, I've discovered that they don't mind going and seeing their clients when they're not so unwell. So, I mean, it's not always a false alarm situation, but if there's a suicide tendency, we can't afford to not go and check. So in that case, the false alarms are not really important. The cost of the false alarm compared to the cost of the loss of a life is negligible. Well, thank you so much for giving me the opportunity to talk to you about this. If you know anyone in the field of wellness monitoring or health monitoring that you suggest I have a chat with, I'd really appreciate that, because I have most of the technology here all ready to go. And I'm very amazed at how I could take my skills in R programming. I mean, I do go back a lot of, back decades in software development, but being able to, struggle through and get a Swift UI app working reasonably well, I think it's a real thrill to do that.
Thank you very much.
Okay.
With that said, that's also the last thing we have for tonight. So I hope we'll see you all next month on the 10th. And thank you so much for coming.